I've got a stream going. It's bright green. I've got a buffer going. We're live. Welcome, welcome, welcome. Welcome to all. This is not Amberskies 2019 C++ game programming. Whoops. Okay, get me sticky notes up. Let's get this organised. What are we? What are we today? We're not grabbing a coffee either. I started this stream dead organised, didn't I? Hey? So that's what we normally are. So cut, paste. And today we are the Amberskies 2019. And this is Q and A. And I suppose we'll put #1. Update information. There you go. That's what we are. We are Amberskies 2019. This is my Q&A. It's Thursday, and I can take that off screen now, I think. Thank you. You can go over here, and we can switch that off. Magic. There we go. Today is just Q&A, and I'll go over roughly what we've done so far, and just any questions that have come up in the meantime. I think that's only fair. So what do we have here? We have a C++ program that sticks square on screen. Wow, yeah, wonderful fun. The biggest problem that I've got right now is that our entity is wrong. So this bit here, let's choose a colour. Red, orange, okay. So this bit over here needs to change. So that's, yeah, we'll just put needs changing, because that's what I'll be working on next week. What we need to do is introduce perspective. So that's going to be developed further, which is why I didn't notate it all up whilst I was writing it, because it's all of it's just, I'd probably just delete those two files. To be quite honest with you, I think we'll start next week by just deleting them, because I know what's in them. I'm not really bothered. I can write it anytime I want. Shaders is correct, so I'm going to tick that lot off. And we need to expand that one. So they need to be expanded. Expand on the ideas of shaders themselves. So there we go. We'll need to expand that a lot. Renderer is functional, if not brilliant. We'll just add 2. So that's just going to be a plus area. Needs to change minus. That needs to expand, so that's a plus. That doesn't matter. The window, we need to finish. I think that's going to be the first objective priority now, is to finish the window. Then I'll have everything I need for the rest of this, because it all depends on the actions and what the window can do. Oh look, I've got a stable stream with no frames dropping. Oh wow, I must have got my calculations right last night. I spent a little bit of a while on that. And yeah, so that's the introduction to what we're looking at today. So that needs to be finished, because we've got shaders, CPP and H finished, so we need to finish that. God, I can't write with a mouse. Okay. So finish that. So today's stream is brought to you by Amberskies. We are the future of 3D networks. The idea basically is your home page. So you will have your PC. So you'll have your PC here. That will have 2 programs on it. That will have a client and a server. And that server will have your home page. Okay. And this home page is 3D. Yeah, 3D home page. Not being seen on the internet up until I do that. Yeah, and that is going to be 3D, folks. So what we have to design is a terrain. Well, I don't know. Terrain, yeah. So, terrain building system. So, that will be a builder. Do I have any coffee left? So, a terrain building system, and it'll also obviously need some kind of asset management system. Now, so I call it a warehouse. There we go. Looking good. I'm getting better at this as I go along. Good. There we go. I need one of those pen pads, don't I? Whatever they're called. So let's send our message out to the folks. Welcome to Q&A. Q and A. Feel free to ask any questions as we go along. I'll just be watching the stream chat more than doing anything else. But I want to talk about this homepage idea first. So what we're looking at? We're looking at a screen with some terrain on it, models on it, trees and stuff. Oh, whatever you want, I don't know. Maybe a house. You know, you can go in and out of the house, you can have rooms, you can have anything you want. You can set it to private. You'll have a private area. So, private area. You might have a friends area. Like inside the house, a few rooms are friends only. So you can have a friends area. Or group area, like party thing. And of course there's a public area. So there will be different levels of permissions, and of course public. We have to include that because it's a web page, don't we? So you could have a store, anything you want really, entertainment, casino, God knows, anything, you know. You can have anything you want on here, doesn't really matter. But private, friends and public, different levels of access. So, don't know if you want security or not. If you're going to ask me about security, tough, I ain't going to ask, I'm not going to answer any security questions. There's a big reason for that, because to answer them would be stupid. Because that's a breach of security, isn't it? So what we'll talk about is a bit more about Amberskies to start off with. So what am I doing? As you can see on the left-hand side, we already have a window, which we're going to finish next week. And we are going to have our colour, our basic colour, fragment and vertex shaders finished as well really next week. So the shaders will be completed. That will automatically expand the renderer, which is good, because I want to concentrate on that renderer a little bit more. It's got to use multiple shaders, it's got to do multiple things, it's got to do a lot of batch processing, that kind of thing. Otherwise, you can't do that. It's impossible to render enough if you're going to start having one model or one entity equals one model. Well, one entity is going to be very little information. One model can be for many entities. So one tree model can be used many times. It's called instancing. So that has to be introduced. So we want to concentrate on the renderer quite a lot. There's also something else I've looked up, which is... Ow. Darn it. I'm trying to open a carton of orange. I finally opened it. Something that we do need to think about is game engines. Are we going to use a game engine? No. No, I don't believe in them. If you can't program it, don't do it. You know, it's one of those things. And, I mean, I could make a shout out to the community here and say, come aboard, join Amberskies, program away with me. You know, I'm quite open to that. I mean, the project just to put a few models upon a terrain initially is going to be a big enough task. So that in itself there is quite a huge task, computer-wise. To get it smooth and at a frame rate of 60 plus frames per second, if I can get batch processing working properly, then yeah. I could get it working at about 1600 frames per second, or actually about 400 to 500 frames per second, to be honest with you. I don't think I'd have a problem with that. Because what you do is you minimize that square. I'm thinking about 30 meters by 30 meters. Maybe. So, what, 30 by 30? I originally went for something like 100 by 100 and ran tests. And the frame rates suffer. So, 30 by 30 came to be a nice visual display sort of thing-ish. So I might go with that. I'm not sure. Does that be M? For meters. I'm trying to think. I mean, people like combat, stuff like that. Well, this isn't going to be a combat program, although the game rules will include combat. But what I want to do is, once I've got this part set up, I want to then concentrate on those game rules. So this will give like access to a home page, and all you do then is look up somebody else's home page and you can go and visit them. So then we'll have home page to home page. At that point we've got a network. So if I can complete that, I've already got the server and the client code sorted for it, and then it just needs the server side to be able to hook up to other servers. So it's going to be a server to server base, and there will be an Amber server to control it. So that will do that. So that will go to a server, an Amber server. So you'd have the central Amber server, or Amberskies server, depending on what you want to call it. That will have access to that only if you wish it to be open. That's an open or shut door. So you will have an Amber server, and of course everybody can log into there, and you will then have a network. So that's really your network controller. So you can go and visit your friends and have a look around the network. And if somebody wants to open a shop, you can open a shop. Now the Amber server itself is going to connect to a game server. Part of the Amber server thing is, do you want to play this as a game? If you do, you have to come out of your own web page and go onto the Amber server or the Amber game server. So you would actually log on to a game server. There's no log on screen. It will do it for you automatically for security purposes. It will have a way of doing it. And that server is the one that I want to try and build here. I've already built the Amber server. I've already got the homepage 3D server sorted out in theory, on theoretical paper. So everything there is sorted out, and I'm happy. I'm happy with the way it's going, so that's okay. So if I want to use a game engine, I would then have to be able to slot a game engine onto a server, and I don't want to do that. I think I would prefer to write my own stuff rather than tailor what I want, which is this, into a game engine, because it just wouldn't work. It'd be easy to do, but it just wouldn't work. I'd be restricted by the inputs. I mean, what does he want? He's just sent me an email. Okay. That's some geezer from the server. I've just been talking about servers, and the server thing comes up, and I get emailed about a server. Thanks. I'll look at that later. How to format servers and stuff. Well, I've got my own private server running quite happily here. Thank you, Mr. Sutter. That distracted me. So I'm not really happy about using a game engine because it would cramp that there. I wouldn't be able to have that control there. And this, when I finish it next week, you'll go, oh my God, that is so fast. It'll be instantaneous keyboard and mouse. It'll have the ability to be, it'll feel instantaneous. It will not have lag. And because the client and the server are on the same machine, there's no supplemental lag introduced there. So you'll have no server lag, because really all you got is one program talking to another program. Let's be honest, it'll never go outside of your memory. Now with memory these days, I could make these massive, but we're only talking megabytes each, not gigabytes, megabytes. So if you've got like 2 gig of memory, or 1 gig of memory on your computer, even if you've got half a gig of memory on your computer, 500 meg computer, you'll still be, it'll easily fit this. Easily. I've got to check on bloat. Did I clear this or not? I will have done, won't I? Let's just pop it up. Okay. I'll just run it. Build and run. Okay, that's looking good. Come on, Microsoft, you can't be this slow, can you? Why, thank you. Right, so that was just my base test information. Okay, that's all the base test information there. Now, what I'm interested in now is how big is that? So, workspace, Twitch, here we go, game, exec. There it is, it's 779 bytes, kilobytes, K. So it's just it's 3/4 of a megabyte. That's big, innit? Now, when you realise that the graphics are all held on the graphics card, all the shaders are held on the graphics card, what is taking up all of that memory is probably GLFW or glue. It'll be one of the things that I've introduced. It'll be an include. So if it's GLFW or glue, this number isn't going to go up very fast if I start concentrating on finishing off what I've started. As you noticed with, I mean, that is, by today's standards, a piddly amount of memory. But you can see that I'm being reasonable when I say I'm not going to get to gigabytes. I might go into megabytes. I might even go up to 2 megabytes. Ooh, very soon. But you're looking at that extra include display window 3DH, because I'm using OpenGL. If you have a look at what it does, by including that, I have these two here, which is your OpenGL stuff. It's so that I can use OpenGL in the renderer and on the entity side, so I can use GL functions. The context is set, and I don't ever alter the context, so the context is set for the program. So it's always going to write out or deal with information going to this window. That's the good side about it. By the time we've finished it, we'll have a couple more functions. It's not going to really bloat the final figure. So if I write down that this week we've managed to program 779K, and we have a look at it at the end of next week, that could be an interesting thing to do. So that means I'm going to do another week's worth of programming here, doesn't it? Yeah. Okay. So let's do week 1 generated 779K of code for the exe file. Check your own. If you've been following along and you've been putting this code into your computer, by all means, have a look. See how much it's compiled to. It's interesting because on different systems you get different compilations, and you can actually get different results. So that's 779K. We've got the basis of a game already now there, but that entity's rubbish. And I knew it was when I was writing it. So, yeah. I wasn't happy about doing that, but I had to do that to get proof of concept that the graphics are working, and they are. 'Cause you just saw it work. But there you go. So that constitutes a game engine, really, in my mind. If you look it up on the wiki, then yeah, it is. It's got purpose. It's got the main game program, which is game. It's got a rendering engine, which is render. It hasn't got audio because I haven't bothered. It's not got physics, I haven't bothered. And artificial intelligence, I haven't bothered yet. So I've got those to do, audio, physics and artificial intelligence. But at the moment, I'm just looking at this rendering side so that we can get to this stage here. And once we've got to that stage, I'll add the audio, the physics and the artificial part, especially physics. Physics will be prime at that point. It'll be the next thing we do. So that is going to be, well, what we're doing at the moment is all to do with rendering. Then we'll do all to do with physics. And I might just throw audio in. Do I have audio? I think I do. I actually think I've got audio because I never ever bother with it. Because it's taste. And there's no way of doing a practical example of audio. So let's think about that for a minute. Audio. There we go. Audio. It's under SDL audio. I thought it was. So yeah, we do have audio. I've got SDL2 as an include. If you haven't downloaded it and put it in, do so. I have on includes under my dependencies. I am using glue. I'm not using the others, just glue. I use GLFW for the window, glue for the OpenGL. I have GLM for the mass library, which if you use it wrong will bloat. This will bloat your file with a lot of rubbish, so be careful how you use this mass library. I haven't had a chance to use it yet, but I know that I will do very, very shortly. In fact, as soon as that window's fixed, I've got to use it because it goes in the window part. We have to put perspective in there. SDL2 is not here for SDL2. Oh my god. It's here because it has this. As a separate download and requires as a dependency SDL2, we have SDLnet, and that's for the network. It doesn't require all of SDL to work, but the networking side does at least require the SDL2's time for timing. And what else does it need? It needs a connection, something to do with connections. Some kind of functionality it needs. I've got a note of it on my server stuff. I'm not looking at that at the moment. But yeah, that's why I've got SDL2 and SDLnet downloaded. If by any chance you have any problems with these dependencies, let me know. Just let me know. And if you want to contact, I've got Discord. I've got Patreon. If you want to, yeah, I'll talk about that in a second. So I've got enough dependencies there for now. I think I've got enough stuff as backup that I can just throw in to see if it works or not. That's good news. Let's clear this window now, can we? Touch writing. Oh yeah, right. Pen. Eraser. Ruler. Okay. Let's have a look at eraser. Erase all ink. Bing! That's what I was looking for. Thank you. Yeah. Okay. So, that was an introduction of where I've been and where I'm going to for this week, where we've been, and next week, where we're going to. So I'm literally going to start at the top, ignoring core because that just gets updated as needed. I'm going to start with display, and I'm just going to work my way down, deleting those two and putting something useful in. Okay, I'm happy about that. So game engines, what are they? Well, look at how they developed. I mean, game engines didn't just appear ad hoc, as if, you know, by magic. Somebody had to write them. And a game engine is rather simple to write, I must admit, as long as you follow, like, basics. As you're going to find out with this, it will be deemed to be worthy of a game engine by the time I finished it. And I could probably extract enough code to make a simple game engine, which I could distribute for you, to stop you having to code it all. But that's not the point. Game engines don't exist. It's just a catchword, game and engine. It's just catchwords developed by the gaming industry to make things like the game engines that are on offer sound good. What they are integrated asset management systems. Or what's on offer is, or are, I'm not going to name them, integrated asset management systems with scripting. And if you make a game using that kind of code, it's never going to run well. Because you are dependent upon your scripts to fit in well, and your way of programming to fit in with what they have already done. Now beware about this. I mean, everybody says, oh yeah, you just use this, that, or the other game engine. And there's very popular ones out there that have done some very popular games. But have a look at some of the AAA titles that have used these game engines and failed miserably. I could name a few. And the reason that they fail is because they don't conform to what the game engine is. The one that they have chosen to use. They haven't conformed to its restrictions very well. And they produced AAA programs which are nearly unplayable because of bugs. And as you know, I don't believe in bugs. There aren't any bugs, there's just bad programming. So at the end of the day, what you've got is AAA titles going out there, charging you 30, 40 quid for an absolute bunch of bad programming. Isn't that clever? Now, I don't believe in any of that stuff. I believe in good programming, solid programming, programming that you can verify to be bug-free, which is what I've got right now in front of me. I've got a program which is absolutely 100% bug-free. And I know it is, because I tested it. And I have tested it extensively. The shading part I'm not so happy about. Shaders, just using Phong as a shader type. Phong shading. Very simple equation. It just uses the amount, it just uses the angle at which light strikes a surface. It's the closest emulation to ray tracing that you can get without actually doing ray tracing. So you create an angle between what you are looking at and with the surface and the light source. And that angle is then used as a multiplier. It's turned into a percentage, and it's used as a multiplier of the amount of light that bounces off the surface. It's a very simple mathematical equation. You're just drawing from, let's see, which way round does it do? It goes, so you get your object, or your surface. You take a point on that surface, and you make a vector to your light source. This is all very important to me, which is why I'm talking about it for some unknown and inexplicable reason. And then you make a, sorry, I don't know how to undo, so just leave the dot on it, it's easy. A vector to the camera in 3D space. So these are 3 dimensions, by the way. Now, if the light was behind the camera, the 2 vectors would be very close together. As the light is reflecting off, there is a zone where you are going to get specular type of reflections, which are very bright. There is an angle here, which can be used as a percent of reflection. And everything reflects. Otherwise you can't see colour. And that was not meant as a nasty thing for anybody who's got any impediment to seeing colour. Sorry. So you get a percent of reflection. That's a T. Now, that's a very simple equation. Because all you've got to do is work out that angle, turn it into a percent, and times your light. Because if you have a look here, colours are in like RGB and alpha. Well, your light is RGB and alpha. It'll be a percentage, so it'd be near 1, 1, 1, 1. So you could use 1, 1, 1, 1, or 4 ones as your light source. Don't. Because it's very hard to take away from. Add more light at that point because you're at max. So never use max light. So you take your percentage of reflection, times it by the colour of your surface, and times it by the amount of light. And there you have what you see. Done. Next. That's it. And that makes that's what they call diffuse light. Specular light depends on that angle being correct. 45 degrees by 45 degrees there. In other words, at a 90-degree angle you will get most speculation. That's a slightly different idea, works slightly differently, but it comes along the same idea. So as you approach the light, the percentage goes up. If you go directly opposite the light, and that becomes 180, that is 0. You won't see, you can't see the object. And if you are looking at the back of the object, if the light can't get through the object because it's got an alpha of 1 and is solid, which I would never advise you do, then you won't see any, because the angle for your camera will hit the back plane. So your camera angle will be on the back of this, and the light will only be able to go forwards, and it will start giving negatives for that percent, which it does on the calculation. It just gives a negative. So that's how it works. I mean, it's quite simple, it's quite easy to do, and it's nice. So there we go. So we'll be doing that next week. You'll see that the equations are very, very simple. But that's an explanation of how I'm approaching it. It's a percentage of reflection of light. So that's all you really need to know on that. Have I got any rants to do? No, I haven't. That's good news. How's that rubber work? Oh, right, okay, just erase all link, it's easy. I don't care about this, really. This isn't important. Okay, quick break. What are we on? 41? I don't know. If anybody knows how to run ads, let me know. I'm going to actually look into that for next week. I'm supposed to have ad breaks, I believe. I'm not sure how that works. I'll get some orange juice. I might have a physical break in a bit. That's nice. Whilst I'm rambling, artificial intelligence is how I actually started programming. It was an interest of mine from a very early age of like 12, 13. And I spent most of my years developing, designing, wondering about, trying out little bits of AI. In today's world, we have things like deep learning and systems like that, which, okay, it's an idea that's progressed. That's all it is. Doesn't mean it's wrong, doesn't mean it's right. It's just an idea that's progressed. The same about anything with computers. Computers have not been developed very well in the last 25 years. We are still with the same basic constructs and same basic viewports and windows that we've had for the last 25 years. Nothing much has changed. They've increased the speed of the chips, they've increased the memory, but the actual basic core of a computer, the operating system, just hasn't been developed at all. It's not being thought about. AAA games today, all built around the same premise. FPS shooters, World of Warcraft, to name the two main formats. And they really haven't been developed or expanded upon or changed into anything else. And it's funny when you look at the history of how they came about, because I've lived that history. I've lived through the development from the first MMOs to what we have currently. And I'm talking about MMOs especially because multiplayer online games is what I've grown up with. So I've seen all the variations and all the problems that have occurred during their development, their history, their playabilities, possibly even their deaths. You know, the death of a game type of idea, which again I don't believe in. There isn't a death of a game, it's just how long or how interesting can a game be every single day after day after day, which is an interesting thought in itself, something that I have contemplated over a long time. So my game rules do allow for that. The problem for me is that you go out there, you buy a game, and you get home, you play the game, it's really awesome. It's an awesome game. You keep playing it and you keep playing and you find faults, so it's not so awesome. You come across some bugs, and yeah, okay, it's still playable. And after a while, you get tired of this game and you move on, and the next new brand spanking shiny new game comes out, so you go and buy it, and you're just repeating what you've already done. So it's awesome, awesome. Yeah, okay, it's still playable. And it's an industry of making games, and the industry isn't now about making games. The industry is about how to advertise your game to make it sound better than the last one that came out. It's all advertising. It's got nothing to do with the programming anymore. The programming, well, yeah. Shall we talk about that? No, I'll rant. Ask me about the programming. Just dare you to. So, programming itself. Is it easy? Yeah. Is it easy to make a program bug-free? Very easy. In fact, the less you know, the more bug-free your programs are. Because you can't put stupid things in there that are going to mess everything up. So as long as you stick to the rules of the programming language that you're using, you're fine. But as soon as you start trying to bend those rules, that's when things get sketchy. Very, very sketchy. I might actually have something on that. My inbox, what is going on? Oh, patrons. Oh, right, yeah, patrons. Patron, that's a good thing. I do have one. 1 second. That's a good point. How can I do this? Right, I've got a Google page here. Where's Twitch? Twitch is here. My page. Channel. Oh, right, that's got a delay on it, you're right. Just below, I've just been, well, today, I've just been typing this stuff out here. Can you get hold of that and copy it? You can. Can you go to your top bar and place that in? You can. And it comes up with a website. Okay. Oh, right, yeah. That works. So, yeah. That was a good bit of an idea that I had this morning. I'll just get that out of the way. So, yeah. You can copy and paste the link. It doesn't actually do the link. I don't think it's not a clickable. It's a copy and paste job. It warned me that things weren't going to, it wasn't a code, it wouldn't run code in that window. So, yeah. Anyway. What did I want here? Information. I was just about to do some information, wasn't I? That's interesting, actually. Oh, we'll just leave it on Google. Alright, what information have I got? No, server design, no. I'm not interested in that today. I'm just wondering why that's empty. I bet I've put it somewhere silly. Oh well. Not to worry, I'll find it some other time. Well, there's about C++. I'll talk about C++ a little. There we go. Started off as C, back in, what was it, the 60s? 70s? I think it came out as the first kind of developments in published in the 70s. Because that's where I remember it. I know it came out, it was out for a few years before I stumbled upon it. It was C, which was my first ever programming language. I learnt all my basics using C. So C++ is a natural extension for that. It's a comfort zone, but C++ is C with added two pluses added. C sharp. If you have a look at C sharp, it's different. It's a variation on C rather than built upon C. C++ is built upon C, and as you may be aware from the last 3 videos, that, well, I've been sort of like sliding into C, then coming back to C++ and sliding back into C, because what I'm using is OpenGL, which is C. So you can slide in and out. We will be going more in depth into C++ as we go, but at the moment, because we are sliding in and out with C, I'm trying to keep things slightly more simple because it helps. It helps with the compilation and it makes your program smaller. There are other languages out there that are built on the premise of C and C++. Trying to think. Like Java. Java runs on a server, which is built with C, possibly C++, but I think C mainly. So that's how that works. It's also used for variations on Java and JavaScript. They are used for doing what Google's doing. HTML Java. Let's have a look. Yeah. Yeah, this looks like HTML. Yes, it is. It's HTML. Java can go into this kind of thing, or it can go into C++ kind of thing. It's pretty interesting thing, but as you can see, just for this guy doing that animation, there's an awful lot of programming involved for a simple animation. You can see the functions. Function C, yeah. So they've had to use C here. So yeah, it's the same kind of thing. If you want to program there's their index. Here's a program. So what they do is, this is a script. They're running a script. Catch. That means I've got to try. Yeah, try catch. Oh my god. We have that in C++. I just don't use it. I should. What it does is it tries something and it catches errors, which I think is hilarious. Stop making goddamn errors. Oh dear. What that means is it's try-catch to protect itself from the operating systems, because it doesn't know which operating system it's running on. Which I agree, use try-catch. Look, they've even titled it nicely. Just send to the console exceptions. Yeah, great. That's really helpful for the user, isn't it? If we are Joe Public and we know nothing about programming and you dump an exception to the screen, that's hilarious, because we don't know what it means. So don't do it. I mean, look at that for a function. A, C, D, E, F, G. Somebody really knows how to make up variable names, don't they? Totally nonsensical. There's a and C, if. Yeah. Oh dear. So they don't try and make it readable. Fine. That's fine. Having a look, see what that system can do. Yeah, right, okay, fine. But that's just for this animation. No, it wasn't try catch. No, it wasn't. No, they actually had a function called, I think receive or catch. I'm not sure. So, 2019 ICC Cricket World Cup begins. Oh, good. Cricket World Cup. Nice. Good effort. C++. It's a language. It's got about 63 command words, and the rest is just style of code. The initial ideas of C and C++ were that you build functions with function names, and then you use and reuse those functions to complete a goal. So it's a function-based programming language. C more than C++. C++, developed the plus on it was development to objects, object-oriented programming, which is useful when taken in moderation and not taken as a must. You must do it this way. There's also classic styles of completing things. Let's see, what information do I have about those? Let's have a look. Coding standards, yeah. These are just styles. So we have header files, which do not get compiled. They hold instructions, declarations of what the program has. They're a bit like when you walk into a cafe, you have a menu. If you choose fish and chips off the menu, then the fish and the chips is what will be provided. So that's how you declare stuff. Scoping is very important and very misunderstood. Classes, can do anything really. You can do anything with a class. You can just, but a class is all about data. You should never get away from that focus. They might call it object-oriented programming, but you should never get away from the focus that a class should have data, or it should be doing something with data, which is why it's called a class. Functions, everything's got a function. Everything is a function in C++ and C. Yeah, Google specific magic, ownership and smart pointers. No, that's C++ has smart pointers. It's not Google specific magic at all. Idiots. Let's have a look through here. Nothing that I can see. You see, that's a library. That's not anything to do with C++. Lambda expressions. You're gonna meet them Monday. Yeah, callbacks. I say that they are. I don't know if your callbacks are actually done separately here. Okay. Naming, comments, formatting. Yeah, Windows code. Exceptions to the rule. Windows code. Beautifully put. I think that's the best way of putting it. I ignore Windows code. Totally. Brackets, yeah. There's nothing really here. I mean, the formatting area look at, but that's roughly about all. Comments and commenting. Yeah, right, okay. Can't see anything here that's useful. But if you want to know how C++ works, I would look through all of this. I really would. I mean, this is part 1 of using C++. Gives you a bit of background, goals of the style guide, yeah. C++ version header files, yeah. Okay, it goes on. Goes on, it goes on, it goes on. Okay. So, Google C++ style guide. Interesting. What else have I got in here? Okay. Okay, input and output. This is an interesting thingy. That's it. Yeah, that is it. Because I think it's included everything there. That's a maths. Oh, right, yeah, you included it. C math. C stdlib. Okay, so that's actually not C++, that is what's in a library. Yeah, most of the things that you can do are in libraries, so you're better off usually looking up the libraries. This isn't really helpful as commands go, so, right, yeah, thanks. How to forge, yeah, right. Let's have a look at that one. Wait a minute, let's have a look at design patterns. I go off topic very easily. So this is what I wanted to talk about. Patterns, thank you. I'm looking for design patterns. Is there a wiki on these or not? Okay. So here we go. Creational patterns. All these patterns are ways in which you can use C++ or any programming language, actually. I don't think it should be... No. I don't think this is limited to C++ programming. I think code pattern design is something that you do naturally over time. And you'll see me accidentally fitting into these different patterns. So the one that I use for, say, servers and clients, I'd use a command pattern. It's an object behavioral pattern that decouples or splits apart the sender and receiver, and it does it by taking to one side a request and making that request into an object, which C++ can do beautifully because you can make objects quite nicely, thereby letting you parameterize clients with different requests, queuing or log requests, and support undoable operations. So you can use an undo. I mean, look under edit and you'll see undo. So that all of this here is using this piece of code idea, the command pattern. It's used for mostly things like that, user interfaces and also client to server communications. That's the way of putting it. Object-oriented equivalent of a callback method, which I'm going to introduce callback. What that is, in the old days we used to call them interrupts because we didn't know any better, and we called them interrupts because they interrupt, but they don't. A callback doesn't actually interrupt as much. You instead decide when you want that interrupt to happen. In the old days, you just interrupted. If a key was pressed, it interrupted your program to register that the key was pressed, and then your program will carry on from wherever it was at that time. Nowadays, what we do is we go through our program, and then at some point we'll go and look at all of these so-called interrupts, which are now called callbacks. We then look down all of our callbacks to see if any of them have received any information. And I'm going to use callbacks for the operating system. So that it doesn't matter which operating system that you're on. If it says a key has been pressed, because the operating system registers that a key has been pressed, then we can take the information from the operating system, which is a safer method of doing it because you're not being interrupted in the middle of doing something important, maybe, like drawing to the screen. You know, interrupts can be harsh. Callbacks are more manageable. That's a nice way of putting it. And it is something that we'll be doing on Monday. Lovely. I think that's gone well. Okay, any questions, any answers? Nobody's asking questions. That's good news. I like it when nobody asks any questions because it means I can ramble on about things. That was C++. Oh yeah. final part of that is this wiki books thingy, contents and all of this lot. If you are interested on design patterns, maybe in England we call it an A level, and then you go on to get a degree, and you've got a degree in computer programming, and you're really into this stuff. It's a good idea to check these out. They are useful. If you are stuck for a way of doing something, use one of these. No harm in it. I mean, they're not bad. They're not don't touch. They are people's experiences over the years in finding a solution for a problem, and this is how they've got past that problem. For instance, doing an object-orientated callback, which is command pan. There's a lot of information there and a lot of ways of doing things that is very, 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 very useful. So use it. Use people's experience. Use my experience. Ask me questions, That's what it's about. Sharing the knowledge, and having standard ways of doing things is always good. I mean, as a kid, how did you learn how to play with Lego? Possibly by trial and error, or by following how to make a house, or whatever, or having thoughts and just making Lego thingies out of it. But yeah, everybody works differently. I have a blank mind syndrome, so for me it's very easy to do anything I want. If I put my mind to something, I can usually achieve it, because I can structure a full simulation within my mind of whatever I'm doing. And if something doesn't look right or isn't working properly, I know about it. So I suppose I'm a lucky programmer. But I would advise everybody does the same. Use a blank mind. Don't try and be the best programmer ever. Just make sure that you program properly. You accept the rules of the language that you use. And if the rules aren't to your liking, use a different language. Might help. Are any other languages easy to learn than C++? No. The language doesn't matter. Programming matters. Learning to program is experience. It's a long haul from me messing around with artificial intelligence. My God, 40 years ago. Yeah. Think about that. Yeah. But I learned to program because I was messing around with things. I did do a little bit of hacking in those days as well. I will not comment on that, and I learnt a lot about security during that time, obviously. So I know how to make my programs secure. And I know a beautiful way of doing it. And nobody will even know that I'm doing it. So, there we go. All programs that I write are secure. So, that's an interesting topic in security that I've just hit on in my mind, on a thread. No, I'm not talking about security. I've already decided. Okay. Well, let's write up this next bit then. OpenGL. My favourite programming language. No, it isn't. Nope, it isn't. It isn't even a language. Very mistakenly called a language sometimes, but it isn't. It's a list of procedures which the OpenGL people get together with the manufacturers of graphics cards and say this is going to be OpenGL blah de blah 4.5 or 3.3 or 4 or whatever. And this is going to be the specification for that and what it is able to do and what commands should be available. The manufacturers go away, make a graphics card with all of these procedures available on that graphics card in a block, chips, maybe written as software, maybe written as circuitry, because a lot of OpenGL is circuit switching on and off. And it's designed that way, and it's been designed very well. So it's not a language. That's the first thing. It's just a bunch of procedures, most of which are switches for on and off. A driver, damn it, I said the word, on Windows especially, is how we find the procedures on each card. So each graphics card manufacturer will write in software a list of ways to get at their procedures on their graphics card. And they'll order them, and then they will number them, and that driver is then accessed by whoever's using it, and the numbers or whatever OpenGL is given to the end user, us, the programmer, as just a list of functions or function pointers, functions that point to where it is on the graphics card. So that's all it is. Glue is just a way of asking the driver for all the information and then listing that out in a format that is accessible very easily and very nicely on the computer for the programmer, and we get OpenGL commands. But when you look at all of those OpenGL commands, it's usually a command, an ID, and an on or off. Or just a command and an on or off. Like GL enable switches something on. Like blending or fog. I wonder if we've got fog. I'm messing about with that again. That's some really good fun with that. There's about 3 or 4 different types of fog on your graphics card. Did you know you get that for free? Yeah, no, people don't realise these days that, yeah, you get that for free. The special effect of fog is actually built into your graphics card. It was designed in 1.1, OpenGL 1.1, and if your graphics card still has 1.1 available on it, or version 1 available on it, they call it nowadays, then you can access it, and you can switch fog on and off. Isn't that ace? You don't even have to, well, you do have to tell it some parameters to use, you know, which circuits to use for the fog, but that's about it. It's not really difficult. I wouldn't mind doing that again. We might, just for a laugh. Well, there's things on the graphics cards that people don't even know exist. And it's harsh. because a lot of graphics programming, especially with OpenGL, is how to create an illusion. The illusion of light is having dark and then light points, or points that look brighter on the screen. And that can be seen in the picture that you see on, well, when I'm off air, a picture comes up, and that picture was taken from Naval Action, which is a 3D game. And you can see how the light has been used beautifully in a very artistic fashion. Actually, I can show you some of that picture. It's below. No, I won't. I'm not moving what I've got on screen. Can I just reduce it to nothing? Yeah. You can see it. Just look at this area down the bottom right hand of your screen. That's how OpenGL should be used. That's an illusion. Those are hexagons put together in a mesh, and then an algorithm to generate the wave formats is used, and there are 2 to 3 layers. One of those layers is a reflection layer. So that layer for reflectivity is the only part that uses light. All the rest are set to see-through or slightly coloured. So as you can see with the wave just above here, it's got a slight discoloration, so it's see-through. So the light is actually passing through that. It looks as though the light is passing through it. It isn't. It's just looking a different colour. But then you've got these little white horses. And if you look very, very carefully at this one here on the left-hand side, you can see how the breakdown of the algorithm is going down on this right-hand side to decide if that should be white or if it should be water. Well, the designated water background. They have it fading. So they have a percentage of whiteness going across. That's an obvious edge there. There's an obvious edge on the little diddy one at the end. And it's all hexagons. And you can't tell, can you? Because the algorithm works on every single point within the hexagon, and then it spreads down all the vectors. And the graphics card does that for you for free. So whoever designed this water is a star, an absolute star, because what they've done is they've then used it beautifully. As you can see with these waves here, it doesn't continue that light reflection from the sun. It stops it, and then the light reflection comes back here, which is very, very, very close to ray tracing. Bet it isn't. Bet it isn't ray tracing. I think that's a simple reflection algorithm, like Phong, used properly. If I'm wrong, whoever the maker of that is, if they want to tell me that I'm wrong, then that's fine. If they've used ray tracing, good on them. But the game will be a lot slower with ray tracing, and it ain't slow. It certainly isn't slow. It used to be, but I think they separated off an extra layer on the water and put the reflection on that separate layer, so that's the only one that had to be processed for light. And hey presto, you get 60 frames per second again. You can multi-layer things. The ship, you can see, I sunk last Friday. Well, the player sunk it for me. It's PvP. Typical. I put myself on a PvP server and get sunk. Yeah. Well done me. So yeah, that's a beautiful use of light. And I like the picture so much, and the usage of the light, and I think it's so artistic, even though I haven't really got, yeah, the drawing technique that I've used on my graphics card isn't brilliant, which is quite ironic, because you can't tell with the water, but you can with the ship. That is ironic. Oh, alright, okay. So, if anyone's got any questions, please, just hold your hand up in chat and say, yay, I've got a question. So now I've described to you what OpenGL is anyway. Yeah, it's a list of functions. Nothing more, nothing less. But some people will call it a state machine, because you're switching things on and off. So after you've switched everything on and off, you then ask it to do something, and it does it. And that's a state machine. Good design pattern, especially for OpenGL, because it means that you can translate three-dimensional graphics into circuitry, and the manufacturers can design graphics cards that work really well. And hats off to them, they do. Which reminds me, what graphics card have I got? Anybody know? Maybe know how to find out? Never mind. Maybe I should look on the receipt I got when I bought the machine. I know it's an i7 processor, but I don't know what the graphics card is. That's interesting. So that's OpenGL. Other languages that we use. That we have used so far. So that is C++, and at the other end of that scale is C. There you go. G, L, S, L. The Open Graphics Library Shader Language. That's what it stands for. I wish they wouldn't use abbreviations, but they do. GLSL is the language that the manufacturers fantastically give us. The manufacturers of your graphics card give us GLSL. GLSL is, I would say it's C, because it's closer to C than anything else, which means you can make very, very powerful programs out of GLSL. Programs that do much more than 3D graphics. Programs that can do mathematics at blistering lightning speed, because your graphics card works at blistering lightning speeds. A lot of time and effort in manufacturing a graphics card is on mathematics, and every single graphics card that you can get has some kind of mathematics ability, and it's that mathematics ability that defines how fast the graphics card really is at the end of the day. So if you've got a fantastic Titan or whatever graphics card, it means its maths is fantastic, and it's very, very fast. And it can be. You can get millions of calculations per second, literally. Millions upon millions of calculations. And they do it that fast. The problem is 1 nanosecond then becomes a long time, because they are that fast. And a nanosecond can really mess things up. And that's how you get glitching and artifacts happening in your graphics. There we go. Just alright, I'm just trying to move my body slightly on this chair. Oh, damn it. So if I've got artifacts and triangles being missed or messed up when your graphics are in operation, especially when running a game or whatever, running your own program maybe, you're getting that kind of thing. It means something's messed up in the GLSL. something's not quite right with your shader program. If you've got the data going into your shader program and what's coming out is slightly not what you expected, then look at your shader language programming, and you can see that I've put mine into these two here. So that's all of my GLSL there. My OpenGL is in there, and everything else is C++. I do have OpenGL splattered in all of this lot at the moment because, well, I haven't cleaned it all up, but yeah. Rendering, by the way, really should be part of the display. Now think about it, because that's what it is. You are displaying your data. So I'll think on that one. I think I might make it part of the display. Because there is only one OpenGL command in it. Yeah. And that's draw. The command to say, go, you got me data, now process it. It's the only command it needs. Everything else is just data setup to run. So that should be easy enough. I might do that actually. Is it OpenGL or is it display? There you go. Open question for the floor. The public can decide, I suppose. So if you're interested, you know, just say, should it, just type in chat, should it be display or should it be OpenGL? It's only got one OpenGL command in it. Which is the reason I put it in the OpenGL. Should OpenGL be in the display? Or should the display be in OpenGL? Ah. Because it is an OpenGL display. There you go, I just knocked it on its head and argued around it. Fantastic. I'm brilliant. Great. No answers, all questions. Great. I think I'll make it OpenGL. I'm going to have more things in OpenGL than I am in display, so put the window into OpenGL because it's a 3D window. Yeah, okay. Never really quite understood why I separated it off in the first place. So there we go. GLSL. If you follow the guidelines of C, and I don't know, there might be a GLSL code. GLSL wiki. Let's see if there's one of those. OpenGL's shaders language, versions, operations, operators. Oh. So there's your version numbers. You have to know your version number. That has to be the first line. Because the graphics card reads the first line to find out which set of instructions you're going to be using. Yeah, that's a bit awkward. There's a bit more information there. To compile it and execute it is done by your graphics card. So there is a compiler and a linker on your graphics card. That is a standard. I don't know if OpenGL produced GLSL and the standard and give it to the manufacturers or what. I'm not sure, but it's the same. It's dependent on your graphics card. It's not dependent on your operating system. So there we go. Other shading languages, assembly. Well, yeah, I suppose you could use assembly. ARB, is that what that is? A high-level shading language for use with Direct 3D. Windows only. A low-level intermediate language introduced by Gallium 3D. Well, I've never come across that. I know there was an AMD thing, but I don't know if that succeeded or not. It's in red. I think it didn't survive. That might only be very, very limited. Vertex and pixel shaders. I don't use the pixel shader. I use a fragment shader. Okay. Fair enough. I've never actually looked at these. Interesting. It doesn't tell you what functions it's got. Yeah, Spear V, yeah. No functionality. That's good. Oh, that's an interesting number. It starts with 0800. Denied. Thank you, phone. 0800. Denied. Ah, I see what they're using the ARB for. Compute shaders, yeah. So there's a vertex and a fragment. Those are the two that I usually use. Shader objects, geometry shader 4. Tessellation and compute. So those are the other shaders that exist on your graphics card. We're only taking the top two because that's all I need for lighting. I don't need anything more. So we're not going to be putting your graphics card under any kind of harsh context. So you'd be alright. And there's not really much here for functions. Utilizes an OpenGL API, which is available on many different platforms. Yes, I know. Okay. I'll stop talking about that bit now, because I'm not getting anywhere with it. Basically, what I'm trying to say is there are specific functions designed for maths on your shader. In your shader language, should I say. Things like reflection are there to help you out, so you can reflect your vectors. So the vector from, say, the light coming in to the camera, we can check the reflection index and create a reflection index, should I say, for that using reflections. We have normalizations, which take a vector and make it 1, which is very, very, very useful because of the way we use our vectors. There are matrices. It's got all the matrices, mathematic ability of a genius. The matrix calculations, even if you don't know what you're doing with matrices and it's just a little black box of jiggly numbers that do special things, this is phenomenally fast. If you are doing it on your CPU side and then passing in a result, that's one thing. But if you're asking then GLSL to manipulate and multiply or whatever with your matrices, you are gaining a heck of a performance advantage from here. This is very high performance even compared to a CPU. Central processing units have a lot to do, and this specializes in just smashing maths to pieces and is really good. So that's why we have compute shaders. A compute shader is specialized in doing maths and computing what do they call them? Algorithms. What the heck? Why do they call them algorithms? They're just equations. So x plus y equals 2. That equation, stick it through a compute shader and it will give you every single x plus y in a flashing instance of what it could possibly be. They're just fantastic. They are just fantastic. Graphics board manufacturers do not get any praise for their graphics boards. Mostly they get negative feedback. I will praise all graphics board manufacturers right now for the amount of care and due diligence that they have in making their systems so good. And they are good. Because as soon as you get a bad one, it's obvious because it's visual. So programming on a graphics card is possibly one of the hardest things to do in the world today. The design and programming of graphics cards. It's interesting that. I would say if you want to be a top-end programmer in today's world, go and look at the requirements that a graphics card company would have for you to be employed by them. Yeah, I don't even think I would get that far. I don't think I would even meet those standards. And that's after 40 years bugging around with this stuff. So, yeah, I think that ends GLSL. It's a program that runs on your graphics card. And you can do quite a lot with it, as we are about to find out after we've finished Windows, so we can get the first bit of information that I need, which is the perspective, because it depends how wide and how high your window is to give that perspective adjustment, so a square will look like a square instead of looking like an oblong, which mine does at the moment. My square looks as though it's like that. Oh well. How nice. So, any questions? That's all about that. It doesn't have to be about programming. I'm not bothered. Just any questions. Don't mind. Erase all. Thanks. So I just wanted to talk about what I'm doing, how I'm doing it, and why I'm doing it that way, and why have I got a dot there already. Oh dear. Right, so let's get rid of that. The format that I use for each video is freeform. It's a freeform format in which we can stop and do anything you like. That's that now. So, questions and answers. Is there anything in here that I wanted to look at? Oh yeah. Biggest question that I've got in here is, yeah, look at the notes on that. Create window. And creates a window and its associated context. So the window is the context. The function creates a window and its associated OpenGL or OpenGLES extended something or other. I think that's to do with Macs, maybe, yes. Can't remember because I try not to use it. And so we get our context, and most of the options controlling how the window and its context should be created and specified within the hints to which we gave, and the hints are just saying, hey look, this is how we want it to be made. Down here we make the context current, So makes the context of the specified window current for the calling thread, which means any OpenGL stuff. It allows OpenGL to know what state it's in. So it gives OpenGL its context. And when you put things into context, they often become more clear and less ambiguous. And that's why OpenGL uses the word context, because the people who wrote this realized that it was the best fitting word for what context is. It's a list of things that have been switched on or off. So when you come to draw or run your graphics card program, the context that it's being run in matters, because that will tell OpenGL what's been switched on, what's been switched off. And so that makes this one single line, actually it doesn't create. That's wrong. Why can't I click on it? Thank you. It makes the current Windows context current. No. It takes, how to word this? It takes the Windows context and activates it. Activates it as, switches it on, really. Activates it as current, using their words. Yeah, it takes the Windows context and activates it as current, because as we just read on that one, it actually creates it there. Get that space out of the way. Create the GLF create window. Create the OpenGL window. Why have I put 3.3 core there? Isn't. We only hinted that it was. No, that didn't work. Create the OpenGL window and context. That is now correct. See, it does help if you read the notes. There we go. Yeah. So now I've noted it properly. But these are the kind of things, how do you know which order to do things in? How did I know about GLF window doing? I read the manual. Yeah, GLFW has a manual. Just read it. I've just downloaded GLM, and I've never used it before, so I've also downloaded the manual, so I can read it. Yeah, I get to read a maths library manual. I'm excited about that, actually, because I don't know what it can do. So the answer is, if you want to use somebody else's, GLFW isn't mine. It's definitely not mine. GLFW is a library that you get online, and it has a manual. So, yeah, there you go. How to use it, and the basics on how to use it I've used here. It gives examples and everything in their documents forum section, and you can ask for help in there. All the GL and OpenGL stuff. Does OpenGL actually have a manual? Because I've never used a manual. I've used Qt. I learnt my OpenGL through Qt. So, like this, that command there is OpenGL 1. I know it's not 3.3. I know it's OpenGL 1. And so is that one. All of this here is OpenGL 1. GL Clear Color, when did that come in? 1.1 area. They've been around for forever. So there's nothing I'm actually using here that I couldn't use 20 years ago, 30 years ago. Yeah, there's not really much that has been developed, and this is my problem. Not a problem. It's not my problem at all. I think it's the industry's problem. That it's never progressed. We're still programming the same way we did 20, 25 years ago. We're still using the same function calls to do the same thing. Nothing's changed. And that's a massive problem. It means that the computer industry has stagnated. And that's the only conclusion I can come to, is that computers today are exactly the same as they were 25 years ago, doing exactly the same thing in exactly the same way. 25 years of stagnation. All they've done is said, oh, but you can buy a more powerful chip, or oh, you can buy a more powerful graphics card, or oh, you can buy bigger memory. That's all that's changed. Size and speed. And is that the way forwards? Is that what we want computers for the next 100 years? No thought's gone into that question. That question's never been answered. It's all been about manufacturers and money. It's been driven by money. There was a system that came out 81 on the chip. There was a system that came out on a chip in 1981 that absolutely blew Microsoft and the PC, the IBM PCs at that time, out of the water. They took a PC and they made it so powerful that even by today's standards, today's PCs can't match it. And that technology is no longer available. Well, it is, if you can find the blooming chip. And to prove my point, I will name the company that designed and devised the chip. It was the Commodore. No. Is it Commodore? Never mind. It was the Amiga 500. It had good RAM, which wasn't particularly fast, or by today's standards. It had a chip, which was not particularly fast by today's standards. But it's what it did with that chip and with that memory, which cannot be replicated today, and has never been replicated since. It used something called bubble memory. And bubble memory means that every single program that you run on your machine is in a bubble. It uses its own memory tables. It uses its own set of resources assigned in a bubble within your memory. And that bubble could move. Your memory was not treated as static, it was treated as a fluid. And that system was the first one that I used for AI with C. And the programs that I wrote no longer work. And I had fantastic AI going. The learning potential on it was huge. And I've been waiting ever since the demise of the Amiga for a computer to come out on the market that could do anything half similar. In the PC world, they call it hyperthreading. Hyperthreading is an excuse that they can't do it, because the technology was destroyed with the Amiga 500. So unless somebody back engineers that now and actually finds out how they did it, the circuitry to make it work, it'll never happen again, I don't think. Ever. I think we missed something. We missed the chance to develop computers that could hold AI. Because it worked in the same way that the human memory works and the human brain works, in the fact that it will create and destroy information. And that information is mobile. Interesting. Other things that people don't realise: C, C++, and any language based upon that. Did you know that programs can talk to each other? These systems for programming languages were developed from Unix. And Unix was a military standard over in America for communications in the military. Literally, military communications. It's unified exchange of information, Unix. Do our programs talk to each other at all? Our operating system does a little bit of that, maybe, using usually C now for operating systems. But we seem to be more internet focused in a two-dimensional way, and I find that a bit surprising in today's world. I think I've nearly gone over the edge into a rant here, because when I switch my computer on, I don't want to see Windows anymore. I don't want to see a 2D screen anymore. I've had enough of that. I want to see my version of my computer world the way I would like it. And that's a long way different. It nearly became a reality with the Amiga 500, because I was generating code at that point that can do the 3Ds that I'm doing now. I mean, all of this program here that I've written so far would work absolutely fine on an Amiga 500. You would see no difference in the speed and execution of the program. That's shocking. I watched a video the other day that said, well, eyes 60 frames per second, it's a big myth that your eyes can only see at 60 frames per second. Well, it is a big myth that your eyes can see at 60 frames per second, because they can really not do well past 25. Yeah, it's a lot lower. And they were talking about monitors and refresh rates of 140 frames per second, and you once you've seen it and you have been exposed to the smoothness of that, that you would never go back to a 60 hertz monitor. And I thought, that's interesting. I'm going to go and I think I'll look into this, because I've got a 60 second frame monitor in front of me. When I'm recording, and what you see on my videos is not what I see on my monitor. That's an interesting concept, because what you don't see is the time lags and blurs that happen when I turn cameras around, say naval action, or when things move on the screen. There is a lag happening, and it's got nothing to do with the frame rate. It's because it's an LED screen, and the switch on and switch off of the LEDs takes time, which means I have screen lag. Yeah, I have a massive walled monitor, and because it's so big, and I mean really so big, that it takes time for all of the LEDs to switch on and off in the right way and give the correct colours and all the rest of it, and change colour if there's motion on the screen. And that's acceptable to me, because I don't mind it, and I know that it's because of the size of the screen. If the screen was a lot smaller, then no, that would not be an issue. It's an LED screen. Would it be any less of a problem for people if I was at 140 hertz? No, the LEDs wouldn't change. They would still have the same switch on and switch off. It would still look exactly the same. Would the animations be any smoother? No. That's completely in the mind of the beholder. After 25 frames per second, it really doesn't matter. It really doesn't matter. At 30 frames per second, you possibly can see that things are slowing down, but you don't ask how many frames per second a camcorder is. If you go out and buy a camcorder, I think they used to call them. Don't know if they still exist or not. It wasn't about how many frames per second they were. It was on the quality of picture. That's what counts. Frames per second was a big selling point for PCs getting faster and AAA games getting more complicated. And I don't know. I think the game industry has run the development of the PC into the ground because of the way that it's tackled these things and used them for advertising on a daily basis to sell their wares. And people now think it's important, and it's not. You should never use FPS as a measure of how well a program runs, because it's got nothing to do with the FPS. It's how well it's displaying it on the screen is the issue. It's got nothing to do with FPS. Ah dear. Bless. And you can prove it to yourself if you want. Take 60 pages or 60 blank pieces of paper, stack them on top of each other and draw a slightly different stick man on each piece of paper in the bottom right hand corner. and then just use your thumb to flick through and do a flick video, or a video flick, depending on how you want to call it. And you will see that the animation is fine. I don't know, ask Walt Disney. He perfected it. He perfected FPS and threw it out the window and said, no such thing, get on with your jobs. And they got on with their jobs, they did what they were told, and they made beautiful cartoons and films. Fantastic artwork. And the FPS, if you ask them, really wasn't that high. I don't think it was 140 frames per second. I think you'll find it's a lot bloody less. Anyway, that's my FPS rant. No bloody such thing. Frames per second is just the electronic scan rate of the computer monitor or TV screen that you use to display whatever you're using, your computer graphics. So if you want your computer graphics to go faster, your TV screen has got bugger all to do with it. If your graphics are jerking and jamming all over the place, it is the fault of the graphics card, not the TV, or the frame rate. It is how they are cutting corners to get something called FPS, which makes that happen. And because they have instilled in their minds that they have to hit an FPS count, they cut corners. Make up systems that run fast, and you can still get jerky, rubbish video from 140 FPS. And I can prove that to you, but I would never lower myself to the standards of programming you have to use to do that. The standards are very, very low. So if anybody asks me, am I going to make an FPS counter? No, I'm not. Will I use one? Yeah, I will if you want. I've got one in Dear I'm GUI, which is a downloadable software for putting Windows within Windows, which I use because it's simple, it's easy, it doesn't cost much in compute time, and you can just slot it in wherever you want. And actually be probably using it for the typing chat system for when we will be chatting on our 3D internet or 3D network. I'll do typing chat before voice chat, because people can use external things like Discord and stuff for voice chat, so it's no biggie if you don't provide it up front and you want to do it later. So priority-wise, voice and sounds, to me, all sound programming and voice chat simulation programmings and stuff like that, IRCs, it's all secondary stuff. Although I am thinking more about sound these days, like the footstep sounds and creepy sounds for scary bits and stuff like that. How you can use sound. I mean, watch nearly all the Hitchcock movies. I know how he did it. So yeah, I have been exposed to sound usage in the film world, and there is a lot of it on TV nowadays. They use sound a lot. I don't watch TV, but I hear it. My other half does. She watches a lot of TV, and she watches quite a lot of the soap operas, and the usage of sound in soap operas is poor, so it's easy to hear how they're using it. And it's sometimes amazing. Sometimes I'll go in and have a look and see what they're doing on the storyline to have them emit such a weird sound or something. And that can be instructive. So I've learnt a bit. I've learnt a bit about sound. I don't normally talk about sound because I don't hear it. I feel it. Sound to me is an experience. It's not something you listen for. It's an experience. If you like a piece of music, it's because it gives you a good feeling, or a feeling and triggers a memory that you want, or something like that. Sound is special and very individualistic. Sound is not something you hear, it is something you feel. I think that's the best way of describing it. And if anybody's got questions at this point, you can do. I'm just rambling on about sound. So if any of our viewers out here want to ask me a question, it is a questions and answers session, by the way. So you can use chat, and if you want to ask anything about programming, you can do. If you want to ask anything off topic, you can do. Ask anything, I don't mind. Ask me about the colour of my hair. It's grey, by the way, very old and grey. Simple, well, the hair that I've got left. Ask away anything you want, I don't mind. So I'll give my viewers a little time to respond there. Thursdays for me is about interaction. I mean, every day to me is about interaction, but Thursdays especially because I like to just sit down and chat about stuff, really. I don't get out much. Okay, I'll rephrase that. I don't get out ever, because I've got nobody to push my bloody wheelchair. So that's that. That's a full stop. So there you are. It's out there. My movement is limited. I don't get out much. So if you want to chat to me, this is your chance. I mean, if you want a real chat to me, this is your chance. Thursdays is the best day to catch me. The rest of the time, I'm usually programming. Okay. Let me post in chat then. There you go. So if you can't see chat and you're viewing, you may have to look for it, especially on a mobile device. I can't find it half the time. In fact, I don't even know where the chat room is. That's clever of me. I need to explore Twitch more, don't I? Really. I mean, it'll make me a better streamer if I do. Because I'm rubbish, really. I don't mind. You can tell me I'm a load of rubbish, I don't mind. My topics and waffle are completely off mark. Well, yeah, of course they are. It comes up on the right-hand side here. Welcome to the chat room. Alright. So it does put it up, and then below it gives my website and Patreon for anybody who wants to support me and support the conquest of the network. When it comes to doing AI, oh God, am I going to have a field day with that? Oh dear. I haven't decided how I'm going to program it yet, and in what style. But it will be fun when I do it. I was looking into something called LERP. And yeah, it's an acronym, I know. I was talking to Sil about it the other day, I think. Sil does a bit of a soundboard for me. He puts up with a lot of nonsense that my brain gets up to, which is good, because it helps me try and work out what's going on. No, nothing in chat yet. My God, what are you lot on? Are you having a coffee break or something? Yeah, they were having a coffee break. Okay, fine. It's alright. Lerp. What does it do? It takes 2 points, or 2 vectors. Actually, I'll make them a bigger circle than that. 2 points in 3-dimensional space, or 2-dimensional space, doesn't really matter. It can be any dimensions you want, as long as it's more than 1. So 2D, 3D, 4D. And all it is a percentage. So if your model is here, we'll call our model M, and it is here between those 2 points, there, then it would have lerped, saying this is a start, and this is the end of its lerp. That distance there is a percentage. It's always a percent. Doesn't matter how far you are lerping, that is always a percentage measure. So your lerp equals a percent along a line between 2 points. And that's all it is. So what you do is you ask your model to lerp from S, from the start to the end, and you measure it by how far it's gone along there as a percentage. And when it reaches 100%, you stop it moving along that line. So to program it, you initialize the start point. You say move to the end point, and the model tools off. And when it gets to here, it's at 100%. So you tell it to stop moving. And that's how a lerp happens. What do they use this for? NPCs. Non-player characters, models or things that, anything that moves in the world will move along a path, a predetermined path. That predetermined path can be anything. Now, when you introduce AI controls that there. So here you can put an AI controller. AI stands for artificial intelligence, by the way, if anybody's not up to date with what I'm talking about here. An AI controller. So we put one of those here. How'd you spell controller? Quick, anybody? God, do I have to look it up? Double L, okay. I can't spell, by the way. So that's your artificial intelligence controller, which determines where the endpoint is, and that AI unit can move that through 2D, 3D or 4D space. So the endpoint is moving, which means your percentage may never actually reach 100. So if, what I'm trying to say is, if you have an NPC coming towards you, and it then realizes it's going to collide, a collision, I'll just call that a col. So you've got a collision going on here. The AI unit will then turn. It will take the endpoint and put it here. The thing will then continue, and it will then do that, and then come back to its original direction. Because the endpoint is still preset. So it has to get to wherever it's going, and it will take any route possible to get there. The route that it chooses is called AI. That's the basic premise of how artificial intelligence works in games and in programs today. So with artificial intelligence itself, is it doing much? No. Is it artificial intelligence? No. No, it's nowhere near. You see, if it was artificial intelligence, it would stop at that point and say, I don't know which way to go. Because there's a choice, left or right. There's two choices, and it hasn't made one. It's been told which way to go. That isn't artificial intelligence. That's just the control of it. The AI part doesn't exist. So, if you see on a game blurb that it has superior or upgraded artificial intelligence, question that very, very carefully. Because at that point there, the easiest way to do it is if you see an NPC walking towards you, stand in front of it. If the NPC stops, then it may have an AI controller. If the NPC turns one direction or the other and walks around you to continue its journey, then it hasn't got AI. And that's how you can test AI very, very quickly. Because you can set this up as a very, very simple program by itself if you want. And you can read out the percentage numbers. You don't even need to have a graphical representation of it. Or you can do it in 2D, so you have got a graphical representation of it, and it's very easy to see because it only takes how much data? About 9 lines, 6 lines, 3. Yeah, 3 lines of data to get a simple picture on the screen and move it around. Yeah, you just use a sprite, wouldn't you? Yeah. Okay, just use a sprite. There you go. And that's how you can work out whether you are creating an AI controller or whether you're actually making a controller. Now, to start off with, you should just make a controller because AI is difficult. AI is very, very difficult because AI doesn't have an answer. It's an equation without an answer. The answer is, does it happen or not? Or every single point on the equation, is this going to affect me or not? It's got to be self-questioning. It's got to be able to decide. And it's how it judges, is that route shorter or is that route shorter? Well, if it hits something somewhere around here, then that's obvious. You get a little bit of movement. But that's not a test for AI. That's a test for a controller. AI is the one that stops. And has indecision. And would print out indecision, stopped indecision, as an answer. There is no answer. It has to have what I call a third option. You can't just have left and right. You've got to have a third option. And that brings me on to the last thing that I really wanted to talk about today, and we're only on Oh, 2.5 hours. My God. Coming up to the last thing. That's nice. I mean, any subjects, chuck them in chat. I'm not joking about that, by the way. Support me on Patreon. You get straight into me Discord. You can come and join me on Discord. There you go. What did I put on Patreon? Was it $1 a month or something stupid like that? It's an American dollar. Sorry about that. It's just how it works on Patreon. Right. So we've been through LERP and AI. Okay. Sound AI. I think I've covered most of the things that a game engine does. Sound AI. Oh God, yeah, there's gravity. Oh God. Gravity. The test that I just drew as well is also a test for collisions. Gravity physics. Or for me, PY phi. I've forgotten how to do this now. Oh God. Yeah, we'll just do physics. Yeah. It's a H. That's what I'm missing, isn't it? Okay. I knew there was something missing there. Physics. Physics. Right, now spelt it properly. Physics. What's on the board for physics? Gravity. Forces. Forces. Force, force, force. If you are approaching programming physics, the only thing you want to program is forces. Why? Because nothing matters. Nothing else matters. If you have a force going that way, which is equal to a force going that way, whatever the object is in the middle is stationary. Only if those change will the object move. So the only thing you're interested in is forces. There will be a force going up, which will match a force going down, which is reduced minus height. Above the surface of the terrain. And that's gravity. Yeah, height. If you notice, that doesn't say what orientation are you at. You could be lying down, falling, tumbling. So, there we go. You may never reach the terrain using that equation. That we will call force G, and that we will call force G, and that we will call terrain. And as you are very close to the terrain, those two become equal. You will not move. you will not go through the floor. How many of these games have you played out there? AAA games, you know, good ones, where you've turned a corner, gone around a corner in a dungeon or whatever, and you've fallen through the floor. And you've gone, reload. How? How is that done? It's impossible, because in that case, what they haven't done is the minus sign very well. Because if it's minus and you go below, then you would have a minus, which is plus. Oh, that would increase our... Oh, I see what you mean. So if you go past the objective, your terrain, you'll keep falling. Oh, and that's your fall through. That's what happens. It means they haven't looked at the forces of what they are doing. They have just said, oh, the terrain is here. We will put your feet at this point relative to the terrain. And when you've gone around the corner, you've hit a spot where the terrain doesn't actually cover properly. As in, the graphics look like that. And they've got a corner. And they are measuring, let's say, on squares. Let's just say they've got a square board map. What about here? Oh, look at that one there. There's one. That's the one there where you're going to fall through. So if you're hugging that wall so you can shoot somebody around here better, at that point there's no floor. Because the floor will only be drawn according to really the whole parts, and anything that's big. Anything that's that small, it won't draw that square because that's expensive. And that's one of the cutbacks that they've made to make it work faster, that all of this isn't drawn, all of this is ignored. So what they've done is they've done a calculation. And as soon as you do a calculation, you've got a problem. Because computers cannot calculate. You have to calculate, computers can't. So you got that little spot there where, by calculation, there is no floor. And by calculation, there is no wall. And by calculation, you fall straight through the floor and into the wherever, into the abyss. And that's what happens. But if you're only looking at forces, terrain doesn't matter. If it's there, it's there. If it's not, it's not. You fall until you hit the terrain, which means every single part of your map has to have terrain. You can't skimp. Throw away your calculations, throw away your textbooks, and think. Because the game programmers didn't. They were taught to do it a certain way, so they do it a certain way. Good luck to them. Not my problem. So yeah, I want to generate a map, and this is why I'm doing terrain first in here. The next week we'll be starting on terrain. I'm hoping we'll get to it because I want to finish display, go through the fragment and colour verts. Shaders are okay. Up to a point. Renderer will be redone, and then I want to get this terrain started, so it might not even be next week, it might be the week after by the time we get to doing our terrain. So this will change. And it's all because of this. We have to have this in mind when we are designing our terrain. Physics. Okay. Newsflash. Just came in from our physics teacher. Our physics teacher has just told me that things are made of atoms. And atoms are made mostly of space. So everything around you is made mostly of space. So there's nothing there. What is solid isn't solid. We just perceive it as solid. Okay, perceptions. So what we need to do is create the perception of a solid. As a programmer. And that's just come in, newsflash from my physics teacher. He was very good, actually. Very good teacher. He's a star bloke. Real star. He had patience of an angel with me. Because I'd complain a lot about the perception side of the things, because I see things differently. I don't look at a solid being a solid. I look at a solid as being a fluid that's static. Oh, we just flashed. Any reason why? No? Good. Right, okay. We just flashed. My screen just flashed. So yeah, bear that in mind. Because if you make everything a fluid that is static, then everything that is static is in a waveform. It doesn't mean the waveform is static, it just means it's muted. So that if you heat up water, you unmute it, you add temperature. You unmute it and it goes from a liquid and into a gas at a certain amount of heat. But even when it's at normal room temperature, it is still unmuting and becoming a gas without any heat input. The heat input just speeds the process up. So the idea of you need to heat something to melt it is wrong. So from a static form to a liquid, that is still happening. It's just like with a liquid to a gas, water, we call it evaporation. Solids turn into water first and then into gas. Does everything act this way? Metals do. We call it corrosion. Because as they melt, the oxygen in the air is able to oxidate or oxidize the metal, and metal oxide is called rust. But it doesn't happen instantaneously. It's slow, so is evaporation. Evaporation is slow because there's no heat being added. If you heat a metal up, it will corrode faster. Microelectronics heat up. And yeah, they corrode faster. Those little legs on those capacitors. That's why the capacitor legs are always so short. Impedance, they say it's to stop impedance. Well, it also stops your legs falling off due to the heat stress you're putting them under. And they do fall off eventually, so, I mean, it's about 10,000 hours at 100 degrees C, and the legs will fall off any capacitor. That's actually true. It's an interesting fact, but so does that mean? I mean, this wasn't taught to us, was it, at school? Oh, well, solids they're evaporating. Interesting idea. Think about it. It's totally illogical. Goes against virtually everything you've ever been taught. Probably, when you start thinking about it, it's a load of rubbish. Yeah, okay, it's a load of rubbish then. It's also true. And that's the problem. The only exception to the rules I can find so far are wood. What is wood? Is it an element? Japanese certainly think so. Yes, my mind has travelled afar. It has travelled to far-off lands to find its equational problem-solving. A Japanese way of looking at things is probably a bit better than the English or Western European way of looking at things. And the Western European way of looking at things is a damn sight better than the American way of looking at things, which is quite strange, really, as they are now the superpower of the world. Strange world we live in, I must admit. My rambles. Physics, sorry. Went off subject, didn't I? Forces. That's all you need to know. We're very, very lucky in computer graphics that we use vectors. We use positional vertices. And they aren't vectors, they are vertices. Please know that one vertex equals positions, I'll call pos, norms, colour, or texture. It also you can add to that I'll call it solidity. Okay. That's what we have for a vertex. That's what OpenGL, the information we want. This is a quickie vertex. It's not a full one. You can have a lot more information than that. A vertex is all of the information that comprises of a point in space. That's a good way of looking at it. It's not actually a point in space, but that's beside the point. Things you might not know about this is how computers actually work with these vertices. It's actually quite strange and very hard to get your head around, so I'm wondering whether I should show it or not. Good question. That might be for next week. Computer graphics next week. It's such a big topic, and we're already coming up to the 3-hour mark. Computer graphics is a massive topic, but we've talked about the physics, which is the last part of what I needed to talk about. I talked about the audio. Talking about a vertex, but vertexes are quite strange because what we are giving the graphics card are vectors. We call them vec3s, vec4s. We're going to be giving the graphics card vectors to work with to make this vertex, like a position vector, normal vector, a colour vector. We actually have colours as vectors within our processing. So these are all vectors. Now a vector is different from a vertex. So one vector equals, and the easiest way I can put it, and I think it's wrong to put it this way, I'll put my disclaimer on here right now. I don't think this is the best way of putting it. It has position. No. It represents a direction. Doesn't have a position at all. It indicates a direction, and it has, most importantly, and this is the biggie, magnitude. Very big, because that means that a vector will give us that arrow, that arrow, that arrow, that arrow. So that's a vector, that's a vertex. Your object is made up of vertices, and these are vectors acting upon that object. So we have to really be careful. And the standard notation for a vector is a line with an arrow, or half an arrow anyway. They cut the other half off the arrow because it got in the way of whatever they were actually trying to say was the letter. For a vertex, it's just whatever. Vertex is a vertex. Call it what you want. But a vector has that little sign above it. And that means it's got magnitude. And magnitude is measurable. And it can be measured as a force. So it could be interpreted as how much force that vector is giving. It has a direction, so you know which way that force is going, and it has an impact value, a magnitude. And it's that magnitude, if we do this right, will give us gravity, proper gravity, in the way that gravity should work, rather than what we believe gravity is. And it's not an illusion. This is probably more correct than the physics way of describing it. So we're going to have to model that. We're going to have to model a force. And a force has to be in 3D because we're going to be using 3D graphics. And this is where I'm annoyed the most. And this here gives me another rant, because physics engines don't work this way all the time, and the best physics engines you can get there out on the interwebs probably don't work with forces. They probably work with detection systems. Yeah. They will have a box, a collision box around an object, and they will use detection of object collisions. That's how this wall is made. The wall has a collision surface, and as your character moves towards the wall, if it detects a collision, it just stops you from moving any further. And you can tell that because if it's a corner and it's like that, you will jutter around the corner, and you can tell, unless they've really, really pinpointed their physics, which they don't usually. So you can actually test how physics has been created within a game that you buy, usually by testing corners. Corners are the hardest part to do in a physics engine, because there's a change of direction, an undetermined change of direction, and obviously you have to be able to represent or take the illusion of a solid and make sure that it stays solid and you don't move into the wall. Now, this brings up a brilliant idea which somebody came up with, and it makes me laugh. So it is part of my rant, but it makes me laugh as much as I want to. It's a roll on the floor laughing job. Most AAA games and MMOs, let's be fair, suffer from clipping. And clipping is where the camera that they are using goes into or past the point. In other words, if you were this person facing this way over, oh god, that's bad, here, your camera can clip here, which means it passes through the wall, or clips, because your camera is not an object, according to their game engine. It's not an actual object, and it therefore doesn't have detection. It doesn't have a collision box on it, and it goes through the wall. And because it does, the way that graphics works on a computer is you can usually see in here, but if somebody's standing over there, you're looking at the back of something. Well, the back of something will never render, because that would be stupid. Why would it be rendered? It means you can see him. Goes through, and then you're looking directly through a wall at a target, and you can click on that target, just as if you can see them by line of sight, because you have a line of sight, which is there. So you can line of sight your opponent, click on them, target them, and possibly, if you've got an AoE effect attack, you may be able to AoE them. Is that unfair? Is it cheating? Is it an exploit? No, it's bad programming. The camera shouldn't be in there in the first place. That's the first thing. Why is it there? Your camera can't go through walls. Don't ever let it. Don't ever make it happen. You know, if you've got a system of forces working on every single object, then it'll never happen. Your camera will just go clunk, and it won't be able to go any further. So the only direction you'll be able to see is possibly a bit more left than that. And if you look a bit more to the right, your camera will come out of there. Yeah, well, it means that your camera will be offset. Or you blank out everything past that wall, so that can't be seen. You refuse to draw anything that is out of true line of sight. And that is where your forces will work for you and auto-calculate all of that for you without any extra overheads, without any problem whatsoever. And that's why we're going to use forces. For my physics, I think I might... PYSX for physics. I don't know what I'm going to call it yet, because it's force, so I use an F, usually. as I'm going to be using the force equivalent of physics rather than collision box equivalent of physics. It also makes hit detection slightly better, but I'm not even going to be using hit detection. So, yeah, go figure. I'm going to use a proper set of game rules instead of hit detection boxes. Oh, poor you lot. Some of you first-person shooters going for the headshots will be really disappointed. I'll let you go for that headshot, how about it? I'll let you target. Yeah, you can target parts of a person. Why not? It's within the rule system. So, headshots are there. That's already been accounted for. Don't you worry, the rule system will cover it. Anything else that forces gives us? Well, yeah, it means that I can draw any terrain I want. I can put anything on that terrain, and that terrain will automatically work within the system. And that is fantastic. You can take things off the terrain, you can put objects onto the terrain, and they will automatically work. So everything to do with collision boxes goes out of the window, and everything just works. And it doesn't matter what the object is. Well, it's lovely. It's a bit like bounding boxes, but it isn't. Depending on the object, or the volume of the object, should I say. I'll work on that part, but it's interesting because it means if you have, say, a wiggly wall like that, you can approach it, but as you approach it, if you get very close to clipping there, you might stop. But there is a path through. But you should stop because you're going to be an object and you've got a size. And if your size goes through that object, in real life you can't have your shoulder go through a wall. Can you? No, you can't. Get to reality, Blades. So no, that you can't do. So you'd stop. You would stop when that part, or any part of here, hits that. Now that's a circle. But it doesn't have to be. I mean, it could be shoulders, head, arms. Let's see, how do we do an arm? Dunno. I suppose. Hands. Each one of these items, everything here, it has a force. So if that comes anywhere near an obstruction that is the right height to obstruct, that will stop and be pulled back. If you walk forwards, that's on a pivot. So if you carry on walking forwards, your arm will be pulled back. And that matters. So you've got to look at pivoting systems as well. But I mean, forces will do that for you. You don't even need to know about pivoting systems to have it work. All that happens is that force there will meet and equal that force there. So that item there stops. And that's your hand. It's a joint to your arm. Your arm's got an elbow and a shoulder. And it will pivot accordingly. It doesn't matter what the object is. Could be a tree, could be a rock, could be a desk, could be a door frame. You know, put your arm down, walk forwards with your arm down, get that bloody sword out of it. Stop it, stop it, stop, you're going ranting, stop. So yeah, it matters if your arms are outstretched or not. So if you are prepared for combat and you are moving around in a prepared fashion, the world around you will be different in the way your character will physically respond to it, because you have changed your shape. Now, to do that with a box system means yikes. But if you do it with a vector system, because remember, we have this here. Direction and magnitude, we have a position. So a position means we have a direction, because if you are positioned there and you are moving, the direction is whichever way you are moving in. So we've got a direction. We have a magnitude, which we specify to start off with, and that has a magnitude of 1, and that has a magnitude of 1 because it's solid. So it'll stop. Because that's solid and that's solid, they've both got magnitudes of 1 or 100% solidity, that will stop. So the magnitudes equal each other, there is no movement. It's very, very simple to understand. It's very, very simple to program. All you have to do is look at the magnitudes. As you approach this item at whatever speed, that point there on your hand will start slowing down. So your arm will actually start moving back because you will be moving faster than your arm, before your hand strikes whatever it is of the object. So it will start happening before. It would be like if you run at a doorway with your arms outstretched, you move your arms before you hit the doorway. That will automatically happen with this kind of system, which is not present at all in any other physics system that I've seen. Reflexes, I think we call them in reality. We have reflexes. We don't like to harm ourselves. We would move our hand. So there has to be an AI unit on there as well for moving the hand, but that's different. That's a different part. AI is different to physics. The physics will trigger something. But there we go. So, we're looking good on time. We're looking good on covered items. I've given, hopefully today, an insight into game engines, or what makes up a game engine. You can decide for yourselves whether I'm making a game engine or not, because if you make a game, you undoubtedly are making a game engine, obviously. So, there we go. I think that about covers it. I'm not sure if I was plain English enough. If any of that was understandable. Hopefully, yeah. Yeah, well, we'll see. We'll see. I'll take questions and answers, by the way. Email address. Did I have that up? It's usually at the top of any of my files. Email. Here we go. DAOC Amberskies at googlemail.com. Mail me. I think this kind of video, because nobody's been asking me questions to answer, and it is more of a ramble through my own mind of really what I thought about things, and I tried to go through a great game engine, as it were, topic by topic. I think this may spark some questions. I hope it does. It would be nice if it does. If not, hey ho, you might have learnt something anyway. So, Monday, stream, usually afternoon, 12, midday, between 12 and 2 I usually start my stream. And I hope to get through my stream before tea time. I'm not feeling particularly well today, so I'm going to be stopping the stream now. But I just would like to wish you all the best. Have a good weekend. If you pop over onto my YouTube channel, I will be streaming games over the weekend. I don't do code over the weekends. I relax and play games. So tomorrow I'll be on my own server, private server that I've got here under me table, doing some Ultima Online. And my mate Sil, special shout out to him. He's given me some prezzies. I've been having a look at me prezzies today. I'll be unwrapping them properly tomorrow during the stream, but that'll be good. That's over on YouTube at Amberskies at YouTube. Just search Amberskies C++. I usually come top of the list on that one. Otherwise, yeah, contact me with questions. I don't mind them at all. Take care and have fun.